Manufacturing Matters is an MFG Radio Network production brought to you by GIE Media's Manufacturing Group as industry experts take deep dives into the latest manufacturing matters, whether it's new innovations, products, technologies, and emerging markets that help you understand better why manufacturing matters to you and also to the top companies in the medical, aerospace, defense, and electric vehicle manufacturing industries.
Hello and welcome, everyone. Thank you for joining us for Developments and Trends in Additive Manufacturing, presented by Terry Wohlers. I'm Elizabeth Engler-Modick, Editorial Director for GIE Media's Manufacturing Group of magazines, which consists of today's medical developments, aerospace manufacturing and design, defense and munitions, and EV design and manufacturing. I'd like to thank our sponsors, Renishaw and Carlisle Interconnect Technologies. Renishaw is a global leader in developing technology that supports manufacturing process control. Renishaw offers an advanced range of calibration, measurement, positioning, and inspection solutions. Specified by leading OEMs around the world, Renishaw encoders, calibration, and measurement systems enable superior process control down to the nanometer and picometer levels. And Carlisle Interconnect Technologies, Carlisle IT. They are one of the world's leading designers and manufacturers of high-performance wire and cable, including optical fiber. Since the company's inception in 1940, it has grown its product portfolio to include specialty and filtered connectors, contacts, integrated systems and cable assemblies, complex harnesses, racks, avionics trays, and installation kits. In addition to its vast product breadth, Carlisle IT provides customers with a higher level of support by offering engineering and certification services for the demanding environments of the commercial aerospace, military, and defense electronics, industrial, test and measurement, and medical industries. For more information, please visit www.carlisleit.com. And today's sponsor is Hawkridge Systems, the leading provider of engineering and manufacturing tools, technology, services, and training in the U.S. and Canada. It is one of the largest award-winning providers of additive manufacturing solutions. Hawkridge Systems also has received the Top SolidWorks Reseller Award several times since its inception in 1996. Its solutions include HP, Mark Forged, and Formlabs 3D printing technologies, Arctech and Creaform 3D scanners, and the complete portfolio of Dassault Systems offerings, including SolidWorks, 3D Experience, and CamWorks manufacturing software. Hawkridge Systems also offers worldwide training through its online store. And finally, here's a little insights about today's presenter. Terry Wohlers is head of advisory services and market intelligence at Wohlers Associates, powered by ASTM International. He and his team have provided consulting assistance to more than 280 organizations in 27 countries, as well as to nearly 200 companies in the investment community. He has authored hundreds of books, articles, and technical papers, and has given keynote presentations on 6 continents. Wohlers has served as a featured speaker in events held at the White House and has appeared on many television and radio news programs. Among them are Bloomberg TV, CNBC, CNN, Fox Business, MSNBC, NPR, and Australia's Sky News. Terry is a principal author of the Wohlers Report, the undisputed industry-leading report on additive manufacturing and 3D printing worldwide. So with that, welcome, Terry, and the platform's all yours.
All right. Thank you very much, Elizabeth. I appreciate it. It's great to be here. I'm thawing out, warming up. It was minus 17 degrees Fahrenheit yesterday at just after midnight. Not this morning, but more than 24 hours ago. But in any case, it's warming up, and the good news is that plus we have a lot of snow in the mountains. So if you're a snow skier or like to ride a board or just play in the snow in general, we have a lot of it here in Colorado. So with that, we will get started with developments and trends in additive manufacturing. Here we go. Good. So for the next 60 minutes, and we'll leave some time for for questions and answers. We're going to talk about growth in the industry and where it currently stands. We're going to talk about using additive manufacturing to create a competitive advantage. Also, some struggle with using AM for series production. Why is that? We'll attempt to answer that question. And then some short-term predictions, really over the next 12 months. Some could extend further, but we're really looking at the short term. And then, as I mentioned, some questions and answers that you might have. So, Wohlers Associates is a part of ASTM International. It was acquired in Q4 of 2021. So, we are more than 2 years into it. This is the Center of Excellence. We're a part of it, but this is the core team, as you see here. And this is the Wohlers Associates team. And you can see that if you add them up, it's just right around 30 people total. And combined, we have a great deal of experience and expertise across many areas, a lot of credentials. It's really a privilege to work with such outstanding people at ASTM International and, of course, Wohlers Associates as well. So this is us. We've been in business for, 35 years when the company was sold in 2021, and then 2 additional years on top, more than 2 years on top of that. So we've been around for a while. In fact, I had the opportunity to really hear about and see the very first additive manufacturing system back in 1987. And that's how far back we go. Our core business is additive manufacturing, consulting and advisory services. And that's, we work with startups all the way to the biggest Fortune 50 companies, government agencies, academic institutions, and really everything in between. We've really learned a lot by working with these types of organizations. And, feel free to contact us. We are happy to answer questions and explore ways in which we may be able to work together. So, growth in the state of the industry. Much of it comes from Wohlers Report 2023. We're currently working on the 2024 edition. It'll be out later. But for now, we're relying on information and data from this publication. And one thing we found just before publishing the report is that the industry has, of course, grown. We know that. But you can see that it has reached more than $18 billion in products and services worldwide. And the products are mostly systems and materials, not only, but mostly. There's software products as well, and then services are service providers of bureaus out there, consulting services, and a wide range of other service agreements, maintenance agreements that support the machines that are installed and used. So we're optimistic that we're going to continue to see growth in the future. It's hard to know exactly where we're going to land at the end of this year. There's a bit of uncertainty, but we take inputs from hundreds of companies worldwide, hard data. And so when we receive this information in the data and we crunch it and we look at it, and sometimes we'll scratch our heads and say, that can't be, or wow, I didn't expect that. You really can't question. You can question data, but you've got to rely on it. You've got to trust it. You can't just use your instincts or flip a coin or throw a dart when coming up with numbers like this. Of course, looking ahead you can, but you can extend growth trend lines like what we have here and see where it lands. And that's a good starting point as to where we're going to be in the future. But we really do rely heavily on hard numbers from companies and other organizations from around the world. And that's how we get this data. It's not just guesswork. The forecasts, there is some guesswork involved there, as with any forecast, but historical data, as you see here, it's all based on hard data. Likewise, we asked about the industrial sectors that are embracing and adopting the technology. And And it might be surprising to some that automotive is at the top. Now, automotive was one of the early adopters of additive way back, got going in the late 1980s and early 90s. But most automotive companies are using the technology for modeling, prototyping, many forms of tooling, jigs, fixtures, gauges, alignment guides, those kinds of things. And a very relatively small amount for actual end-use production work, serious production, or even custom. We'll talk about that here shortly, but that's how the auto industry is putting it to work. And then comes our consumer products, aerospace, and the rest of them. Others, so there's a relatively large category of other that don't, fit into these industrial sectors. Marine products would be an example. So you can see that the architectural and construction industry also has moved the needle a bit, and we'll talk about it shortly as well. This is something we found interesting back in the 2021 timeframe. You can see that the blue line represents photopolymer sales. So that photopolymerization, also known as stereolithography, at least that's one form of it. And you can see that it has been the leading in terms of material. It has been the leading material type for many years until 2020. That's when it started to cross over. It's still a little bit more than polymer powder bed or powder cells, rather, mostly for powder bed fusion systems such as laser sintering. But then you can see it's really separated in the last couple of years, or at least 2021 and 2022. We'll find out what 2023 brings. But so this is powder feedstock for powder bed fusion systems compared to photopolymer cells for flat photopolymerization systems. By the way, I'm using ASTM and ISO terminology. So the world has gotten. Next slide. This shows the sales growth of AM systems for metal parts. You can see that it really flattened after about 2018, but then 2 years ago, it really started to, or 2022, started to climb again. It's hard to know for sure what 2023 will bring, but I'm optimistic. This shows the number of industrial AM system manufacturers that are producing industrial systems. So industrial systems we define and have for many years as machines selling for $5,000 or more. Right or wrong, that's what we used more than 10 years ago. We stayed with it. One could argue that some under $5,000 machines are being used for industrial applications, but this is a methodology that we stayed with. So you can see that, now just to be clear, this is not the number of systems, but the number of companies that are offering systems, industrial systems. So approaching 300, which is absolutely remarkable. If you look at parts of Asia and other parts of the world, it's just really it's almost unbelievable. The second bar shows the number of these companies that have sold at least 100 units. So it's one thing to sell 3 or 5 machines in a given year, but it's a whole nother to sell more than 100 machines. And you can see that, relatively few, more than 40 have sold at least 100. But that's still a fairly significant number of companies that have sold that many machines. And then this shows we're really shifting now into applications, how companies are putting AM to work. And you can see that end-use parts and functional prototypes really represent the majority. In fact, it's approaching 60% of the total. So companies have a strong appetite for functionality. And you can see this. You can't really produce parts that go on to final products unless they're fully functional, unless they're purely aesthetic type parts, which can be and sometimes is the case. But often when we're talking about functionality, we're talking about parts that perform in some fashion that require some level of strength and endurance. And so then you can see the other applications of AM. And so companies are using additive manufacturing to rethink product development, to really generate new streams of revenue and to help create a competitive advantage. So let's give some examples of how this is occurring. Olaf Diggle, one of our associate consultants, longtime associate consultants, he's a designer. He's a brilliant designer in my view. He has designed some amazing products. Here's a radiator that he designed using a gyroid interior of the radiator. And this is a heat exchanger on the right, and also using a gyroid configuration to produce this particular product. He did the design work largely with SolidWorks and some other tools. He uses a wide mix of tools, and then he imported it into NTOP, formerly known as N topology, and he generated this interior in 1 minute, which is pretty interesting. The speed at which you can do these kinds of very complex designs. This is a similar one for a military helicopter, and you can see that it really does look somewhat like what Olaf Diggle had done. This is not a Diggle design. What's interesting about this one is it's half the size of the conventional version and 4 times more efficient using this gyroid infill, which is really a perfect fit for heat exchangers. It really is really designed for this type of application. I was told by Brian Neff, this is back in November in Frankfurt, that a heat exchanger has been certified for use on the F-35. And I asked for images and more information about it. Now, maybe in a year from now, we'll get that. For right now, they're keeping, the military is keeping that to themselves. But it just goes to show that these things are just for show and tell. Of course, they are for that, but they're going on to a real serious product such as this one here. And the technology uses metal powder bed fusion typically for this type of application. Moving to polymers, this is I still think it's big business. It isn't today for a company like Smith that makes sporting good products such as this ski goggles. It's a small business, but it's a start. And I think if you fast forward 5, 10, 15 years, it's going to be significant. I don't know if it's going to be this product for this company, but these types of custom and in some cases limited edition products will grow to be big because people will pay a premium for it. I paid, I don't know, maybe $75 to $100 more for this custom product, which I own. This is a scan of me on the left. There's a little phone app that you could do it in a matter of a couple of minutes, provide the data to Smith. And then I think it took a couple of weeks to get the custom goggles back. The parts that you see here, the polymer structure, that's the main body of the product. It's all 3D printed using the HP multi-jet fusion machine. And then the lens and the rest of it, and of course the strap are our standard product, but they fit like a glove. I like them a lot, and I use them last week. I'll use them later this week. So it's a good product, but this is enabled through 3D printing and additive manufacturing. So it would be impossible. Yeah, they have this product, the same product, but it's they have a standard version. And if you want to pay a little bit more, you can get one that fits your face perfectly. Okay, let's attempt to answer this question. Why do some struggle with AM for production? Now, most companies, I can't say many companies, thousands of companies use additive manufacturing for prototyping and some forms of tooling, getting some hardware in your hand quickly to evaluate the design, to compare several competing designs. You might have 5 ideas for a new mobile phone, for example, or whatever it might be. and you can print those and put them side by side and narrow in on the favorites. And so companies continue to use it for that type of application and many others too. But really the biggest opportunity in my view, and I think many will agree, is to really take it into actual series production or custom production. And it could be mass custom production. It doesn't have to take a line, for example, which, Invisalign is the product brand that most hear about. Invisalign, that is mass customization. I mean, they're producing millions and millions of these things annually. The dental aligners, each one is different. Now, they're not printing them directly, they're printing they'll call it a form or pattern over which they thermal form the material to produce the actual aligner. And then there's a lot of automation, a lot of other technical things going on to produce the set of aligners to straighten teeth. But that's doing it in high volume, each one being very different and patient specific. Design for additive manufacturing is really something. It's not simple. Design for AM is not terribly difficult, but to do even something like this, taking what normally would be sheet metal and then turning that into something that's closer to what you see on the right, using topology optimization and maybe some other forms of design methodology is not trivial. It not only requires tools that can be relatively expensive, but it also requires expertise. And so you can envision a company that wants to go down this path with, it might be engine parts, suspension, it could be, machinery, you name it, consumer products of many types that want to do this kind of work. And it requires, like I said, an investment. And in order to really create a justification, a business case around it, you've got to go down the path of ways. Now you can outsource some of this, maybe all of it, at least initially, to determine whether or not it makes sense for your particular design or designs. But regardless, it's going to cost some time and effort and money to get it done. And my belief is this is one of the biggest reasons why companies push the pause button when they get partway into it. They say, whoa, we got to do this, this, and that, and spend this amount of money and time, and then to even determine whether or not it makes sense to use additive for production. And this is a relatively simple example. Envision something highly complex, an aerospace application, or maybe a medical application where the risk is high. There's a lot of obstacles that get in your way, reasons why you don't want to do it. And you can line up many, and design is one of the challenges. This is another, qualifying processes and materials and then certifying the designs. In aerospace and medicine, it can take years for these things to happen. And there's, no guarantees that it will successfully. And standards really help us when in product development and manufacturing in many ways. And fortunately, we do have standards in additive manufacturing. Do we, are we finished developing standards? No, we started back in 2009 when the ASTM F42 Committee on Additive Manufacturing Technologies was formed. I was lucky enough to be a part of it for the first 5 years. I really learned a lot about developing consensus standards worldwide. And so it's a journey. It's not a destination. Of course, you want to publish as many standards that can be helpful to organizations, but we have many out there today. It's a work in progress. We need more to help companies get move more quickly in the beginning, so that they don't have to do it themselves, bear the brunt of developing these in-house standards. And some of those, of course, are naturally will occur naturally, and so, but to have a starting point really is very helpful. And then the return on investment. There's just so much uncertainty when going into production application, knowing whether or not It's really, you're gonna get people who throw up roadblocks and say, no, you can't do it. And it's quite easy to revert back to the way it was done previously. And I guess until a company is pressured competitively, often that's what they do is they just say, nah, we'll wait until maybe the technology matures more. So, but we have seen some industries like the dental and hearing industries where, the in-the-ear hearing aids, really, most of the major manufacturers were pressured competitively to use additive manufacturing to produce the custom fit shell that houses the electronics. So they were, and that's an example of where a company, they felt like they may go out of business or they would be at a distinct competitive disadvantage if they didn't adopt the technology for production. And they did. In the dental aligner business, same thing is happening today. And so, well, in other types of dentistry too, we're seeing for dental models and drill guides and so forth. But yeah, it's interesting to watch industrial sectors and how they behave, based on, is a major competitor doing it? If they're not, then maybe they will. Some additional predictions or some predictions for 2024. We're just now getting into that segment here. And the first is the increasing importance of the carbon footprint impact of AM. Now, if you back up even 5 years ago, certainly 10 years ago, it wasn't even on a company's radar for the most part. There may be a few, there's an exception, but the rule was, they had bigger fish to fry than this. Today, I'm at least hopeful that when companies are making a purchase or an investment, they look at this and they say, how green, how much impact will this process, material, or approach be on, our planet? And I want to applaud this organization off to the right. We don't have any formal affiliation with them, but I did attend a meeting in Frankfurt and was happy was invited to speak, and I learned a lot about this relatively new association, and it's one to watch and one to look at how we can support not necessarily this organization. Please do if you can, but other organizations too that are really working hard to provide some guidance and clarity as to what processes and materials can really. And the thinking behind being friendly to our environment. One thing that is interesting is this: if you take the design on the left and you redesign it to, in this case, one part. This is a real job from GM. You're going to save a lot of time and money on manufacturing processes, because the version on the left requires many different processes and part numbers, inventory, assembly, even maintenance could be higher, and certification paperwork compared to the part on the right. When this is the case, it often is also more friendly to the environment. The carbon footprint has been reduced. And so they go hand in hand. It's a win-win-win. You save time, money. You might even have a better performing part. And also it's better for our environment. So it's something to think about. And here's another example where you have 16 parts on the left, all metal, including the fasteners, redesigned to 3 parts in PA12. It's a nylon type of material. And you can imagine the energy impact, how much energy is required for these 16 parts versus 3 polymer parts on the right. So this is something that companies really are looking at today, whereas just a few years ago they were not. So this is something I think we're going to see more of this year. I think the automotive industry is going to embrace the technology for actual series production more this year than ever in the past. And this is a company that Divergent Technologies, sister company, Zinger, and this is the chassis of the Zinger sports car, Zinger 21C. And you can see a lot of these parts, the chassis, the suspension, brakes, a lot of the parts were consolidated, reducing part count, and then also optimized to reduce weight and performance. And so this is not just a sports car, but the company Divergent delivered a 30-kilogram aluminum chassis to Aston Martin in 2022. So this is real. This is now it's a low volume car in the hundreds or a few thousand, but still it's a start. And this is the one of the reasons why what normally takes 2.5 to 3 years, the company did in 3 months. And so it's really speeding things along. These are some images I took last year, integrated suspension and braking system. All of the suspension parts are not there, but with integrated hydraulic channels within what you see here, which is really interesting. The company Divergent is producing parts for hundreds of cars today. They believe tens of thousands by next year and the following year. So they're really ramping up, but they're setting an example of what's possible in the automotive industry, where the big OEMs and their the tier 1, 2 suppliers, they're not yet there, and so they're providing some new ways of thinking and showing that hey, it is possible. Divergent rather is working with 8 OEM car brands, mostly in Europe, and these are some of the brands here, and they are working with more than 20 production platforms. Just looked over at my internet connection. Looks like we're still up. Some other predictions. Well, this is the Cadillac model that will become available this year. And this is relatively new information. So they're producing many parts by additive manufacturing. This is the steering wheel. You can see the steering wheel on the build plate on the left, and they're printing it in the aluminum. And of course, it's being covered, as you see in the image on the right. 115 aluminum, stainless steel, and polymer 3D printed parts for the likes of window switches, grab handles, decorative pieces, and other parts. They're using metal binder jetting, which is really an emerging technology. It's been around for a few years, but now it's starting to gain some traction at companies like GM for certain types of parts, and then metal power bed fusion and HP fusion as well. And this is the first safety related part. It's a seat, they call it a seatbelt D-ring. It's part of the seatbelt assembly. So yeah, so it's great to see GM pushing the limits here as well. This is some work in Japan, and this was shown at the Tokyo Big Site. Back I'll be there end of next week. The bottom week that show. And so, would I drive this car? I don't know. Probably not. It's a concept car, and it's all electric, which certainly embrace the idea of all electric. And it includes many 3D printed parts, and you can customize the product. But it shows what's possible largely through additive manufacturing. And so I can see it. For years, we've talked about the concept of digital inventories and on-demand manufacturing. So the conventional approach is to manufacture based on a company's forecast, sales forecast, and then you put these parts on shelves, and then you assemble them, and you send the product out and you sell it, and sometimes long before, depending on the distribution channel and so forth. This is a different idea where you store the inventories digitally in a computer on servers, and then you manufacture on demand. And it helps to produce to support the idea of semi-custom designs, because since you don't have physical parts sitting there in inventory, you can customize and then print on demand. And so that really adds value and increase profits. So will this occur largely in 2024? My view is this, that it's so much in concept, it sounds great, but it's so much harder to get done than is possible for most companies. I'm not saying they can't, but it's a challenge. And it's not something that, it's not like flipping a switch. It's not something that you can do in a short time. You want to, find the low hanging fruit and start there on those types of parts and products. And then over time, work toward a fuller inventory that's stored digitally. The difficulty this year in the short term is the upfront costs and the ROI certainly linked to this approach. But I do think over time, the next 10, 20 years, we'll see some real interesting movement in this area, but not much this year. And I mentioned qualification and certification. I just want to underscore the challenge here with companies that, especially the regulated industrial sectors. But I think with that said, companies are working really hard and they have methods and the thinking in place to make it happen. So I think we're going to see some real movement and progress in terms of streamlining the qualification and certification process around patent manufacturing this year. And ASTM International, I think, is doing its part, our part, at least we're trying in this area when you look at all of the other area elements that really make up the system. Additive construction, I promise I talk about it a little bit, and I will. My father was a building contractor, grew up in Nebraska. I was on a roof at age 5. I'm not sure that was the safest thing in the world, but I was. And I really, I got my hands dirty. I really learned by doing, and then helped pay for my tuition and other expenses going through my 4-year undergraduate program. And so I really learned and I think appreciate construction methods and materials. Am I up to date today? No, I'm not up to date when it comes to methods and materials. It hasn't changed a lot, but I've got dabbled in a little bit since then. But the point here is that if you're built, certain structures make a little sense. They have little value to a building, for example, or some structure. Does this make sense? Well, I think so. I mean, this could add value. I mean, it structurally, I don't know about that. It looks like it's providing some strength and structure but from an aesthetic standpoint, it provides something that versus just straight square walls does not. It doesn't. Just like with all types of additive manufacturing, if you're doing something really basic, prismatic type shapes, maybe there's a better way, less expensive and faster and better way to do it using conventional methods and materials. So, the industry is sorting itself. I mean, it's really thinking through where can additive manufacturing, additive construction add value. We're seeing so few, in fact, I've really seen like zero real independent use cases with cost justification numbers. Most of the cases that we've seen in the publications and at industry events are those who have something to gain by promoting the idea. And so I want to hear from those who are 100% independent. I want to see the real numbers. I've yet to see them. This is interesting. This is at the Singapore airport. It's not providing any structure, but it provides some aesthetic value and architectural creativity. I think that's where it seems to me an obvious place to start. And companies that are learning more about this are doing it, but many are not. And so I think it'll take some time for them to really sort it out. So I promised to leave some time for Q&A, but first I'd just like to summarize by saying, that the industry remains strong. Now, has it weakened some this past year? Possibly. We're seeing a lot of activity with mergers and acquisitions and share prices not being where people would like to see them. Some companies are struggling, but then I'm seeing some companies doing very, very well and being very creative with their work and doing great in their business. So it's a mix. So we're getting those numbers as we speak, and we'll be publishing them later this year. I think our predictions reflect strength. Of course, I'm optimistic, but I'm also very realistic. And I can be even a little pessimistic or a skeptic, I guess is a better way to put it. Like, for example, the additive construction, having gone through it from the late 1980s to 37, 38 years later. Is that right? I think that 35, yeah, 37 years later. I can't say I've seen it all, but I'm always skeptical when somebody introduces something and they say it can do this, this, and that. And so I think it's good to be a skeptic, to talk to the actual users who have nothing to gain, the customers, talk to them, and you often get a different story. So I urge you to do that. That's so very important when making a business decision around investments. And some applications, such as heat exchangers, can really move the needle in some areas. So I mentioned the hearing aids, the dental applications, aerospace, medical devices. I mean, companies, are in some cases are investing hundreds of millions of dollars and really doing, interesting work. And so they are absolutely moving the needle. Yet some struggle to use AM for production. I think, the risk and that ROI and uncertainty that I mentioned earlier, that's the, in design for additive manufacturing. It's not something you can just do in a few weeks. It takes months, if not years of practice to really, not that it's going to take years for these companies to really, you can get people who have experience and contract with companies who have experience to really move more quickly. But it, still can be a struggle. And design is absolutely playing a big role in the adoption. And then design for additive manufacturing impacts the carbon footprint impact of additive manufacturing. So with that, I will close. And we have about 12 minutes or so for questions. If you have any, I'm happy to answer, at least try to answer your questions. So please feel free to fire away.
Okay, we've got the questions pouring in here. We're going to go back to the seatbelt D-ring. What material and printing method was used in producing that seatbelt D-ring?
Yeah, I don't know what is a metal. I didn't ask. Brandon White is the person at GM that reported on this in an article recently, and I was in touch with him soon after that, and I could make contact with him and find out. I also looked like it could be possibly stainless steel. I think it was stated that aluminum, stainless, and polymer are the materials that make up the 115 parts. So it was either aluminum or stainless, but my guess is probably stainless.
Okay, and we've got a few more questions based on that. Lucy wants to know, how are these safety critical parts certified? Is it all based on physical tests, or are designers able to use known data sets for the material properties and computer modeling?
Right. So the data sets are typically used to qualify a process and material, and the parts are certified really using maybe slightly different, but largely similar to other methods of certifying parts, whether they're automotive, aerospace, or medical devices. So, long before additive, we had these certification processes in place, and so they have to go through the same kind of rigor. Testing and so forth that conventionally made parts have to go through, maybe even more because they're made in this way, at least at first, until confidence and methods are really fine-tuned. So yeah, that's my answer to that question.
Great. Now, Chris has a question. How do you see the ceramic SLS powder bed market developing over the next few years?
The ceramic market, well, that's a niche, and there's riches in niches. That's something I learned a long time ago. And it can be, I mean, it can be lucrative. It's a very specialty market area. Ceramics are used in a wide range of areas, but it's today it moves the needle but barely in additive manufacturing in terms of activity, both machines and material sales and actual use. And so forgive me, Elizabeth, but the question was what around that?
He wants to know how you see the ceramic powder bed market developing over the next few years.
Yeah, I mean, if we can rely a little bit on history, it has developed, but it's been relatively slow for more than 20 years. And I expect to see more progress, but I don't see, I mentioned that the forecasting and predictions, one way to do it is if you can plot growth of, say, ceramics over the last 20 years, just extend that growth trend line. You can do that. And that usually is a great starting point as to where it's going to end up. Some innovation could bend it upward so it grows much more quickly, but we've had, not that we won't see that, but like I say, a good place to start is just extend that growth trend line.
Great. That answered a couple of questions because we had a few people asking about ceramics. Len wants to know, how are companies changing how they engage with their markets? Who are they speaking with in client firms?
How are companies changing and speaking to clients?
Yeah, I'm assuming that Len is asking how are they changing how they engage with their markets if they're coming with additive manufactured products.
So the parts and products coming off of the machines, not the companies selling the machines. Maybe if he wants to provide some clarification, I guess I can start with the former, the parts and products coming off of the machines. So how are companies changing their approach to working with customers, or maybe getting the word out to customers? Is that a question?
Perhaps, Len, you could clarify your question a little bit and we can jump to the next one. Okay. What medical devices are mostly produced using additive manufacturing is the next question.
Which medical devices? Sure. If you include dental, it's a big area. Dental models, crowns, copings for crowns and bridges. Some not conventionally made, but metal braces that would maybe a little bit closer to conventional types of metal wire brackets and braces, but maybe a little bit different approach. Of course, the Invisalign, but maybe he's talking about more non-dental. So in that area, we're seeing early on, and we continue to see it today, medical models to help plan complex surgeries. And so whether it's cancer or gunshot victim or something else where it could be a cranial or maxillofacial type and head and face type injury or condition where they need to open them up. They can do CT and MRI scans, use that data to drive the machines to build models that they can plan these complex surgeries. They can even go as far as to sterilize those models and take them into the OR, and so that they can refer to them. If you're getting a mandible or some other facial part being built, they can in advance fit those to the models to make sure they may have to do some fine tuning once they open up the patient, but they can do that largely in advance. And so that's some of the early work. We'll continue to see a lot of that today. The likes of Stryker, Nano Corporate, the Pew Biomed, and other orthopedic manufacturers are producing hips. In fact, I spoke with a person just on Monday, or was it? No, it was yesterday, who had a new hip. It was a Stryker hip. That was his first day back to work, and he has a 3D printed hip from home set up. Now, it was not custom. That's sort of a misconception to think that because it's 3D printed, it's custom. Most of them are not custom. The hips, it's typically the acetabular hip cup that is produced, and then the standard parts for the rest of it. But those are being produced, and not for 100% of the hips, but a lot, tens of thousands, might even be hundreds of thousands today. A lot of spinal implants too. Many spinal implants are being produced. There again, these are series production, not custom. They are standard products in different sizes, but they're being 3D printed because they can produce a superior product. They can produce a rough, porous surface that encourages osteointegration, which means the bone then it better adheres to the implant. In the case of, in all these cases, really, or most of them, when we're talking about an implant. So I probably missed some areas, but those are two of the biggest in my view. We're seeing some prosthetics and some other work being done, but in the medical field, the medical modeling is providing a great value for complex surgeries, and then these 3D printed orthopedic parts, not only hips and spinal parts, but those make up the lion's share. We're seeing also shoulder parts, hand and wrist, foot, and of course the head and face as well.
We do have another question coming in. Well, Dean wants to know if the slides will be available afterwards. I don't know if we will upload the slide deck, but we will have the recording live. And we will work with Terry. And if we do put the slide deck up as a PDF, we will let you know and include that in the post email. And let me get to a few more questions. What do you think is driving the consolidations and mergers that seem to be going on in the market?
Well, consolidation is inevitable. If you look at the automotive industry from the last 100 years or so, we saw a lot of that. And most industries will consolidate. And why is that? Why do companies consolidate? Well, there's usually one or two ways to grow a company. Suppose you're one of the companies out there and you want to grow, you can grow organically. And that typically means through increased sales. You sell more this year than you did the year before. That's growth. Another, you can grow through acquisition. So now you're at least in theory, you produce more money because now you have more than one revenue stream, assuming the company you're acquiring is producing money. And then you have potentially more resources too, maybe a bigger distribution channel, engineering could strengthen. There's a lot of reasons that you might want to maybe buy a customer base. Like this competitor has a lot of customers and maybe they're a little bit weaker than you are now. So you acquire them and suddenly you gain all their customers. And maybe that's the biggest value. So there's motivation to looking at acquisition. And then from the sell side, since we sold our company, you look at people like founders. They at some point decide they want to throttle back a little bit, maybe ski more, spend more time with the family, travel, whatever it might be. And so that's a motivation to then sell your company. And when the word gets out that this company is available, then that sometimes it years work up, and that's how it happens. But yeah, we are definitely going to see more M&A over the this year and in coming years. That's inevitable, and those are the reasons why.
Great. And I think we're going to sneak one more question in here. Eric wants to know what the material jetting AM process market looks like.
Material jetting and process market, assuming was it Eric? Yeah. So material jetting, it's one of the 7 popular processes defined by ISO and ASTM. And so you're jetting material using the inkjet printhead to deposit material layer by layer. And so A couple of the companies that have, or at least one that comes to mind immediately, as opposed to binder jetting, there you're using a powder bed and jetting we'll call it an adhesive, but a binder in this case, you're actually jetting the material itself. And so like the company Object that merged with Stratasys a few years ago, it was all about jetting material jetting. And today, you could argue that it's, at the forefront of jetting, not only in a monochrome way, but color material and translucent material. In fact, I have one here. It's a beautiful piece done on actually the Mamaki device. I don't know if you can see this. This is a human body. And the Mamaki is a Japanese company that produces a machine that competes with what the early versions of NJ50 from Stratasys that could do full color and even transparent or translucent parts and products, and beautiful. I mean, the work that goes into this is just stunning. And so this is, the bones, the organs, the arteries, veins, everything. And it's just a really cool work. And that's what's possible with material jetting that really cannot be done with powder bed fusion or material extrusion, for example. So it has a place, it has a place. I can't say that it's going to take over or dominate, but for certain niches, it does well. And so, whenever I see new models, typically ones from the human body or some, shows the interior or something, really stunning, absolutely is.
Wonderful. Well, I think we are going to have to wrap it up there. I apologize for anyone whose questions we did not get to. And again, thank you, Terry, for a wonderful presentation. And I'd also like to quickly thank our two sponsors, Renishaw and Carlisle Interconnect Technologies. Renishaw, who is the global leader in developing technology that supports manufacturing process control, and Carlisle Interconnect Technologies, one of the world's leading designers and manufacturers of high-performance wire and cable, including optical fiber, and Hawkridge Systems, the leading provider of engineering and manufacturing tools, technology, services, and training in the U.S. and Canada. So thank you, Terry. We always appreciate kicking off our webinar series with your insights.
Thank you, Elizabeth. It's my pleasure.
You can listen to all of our episodes of Manufacturing Matters and Lunch and Learn podcast from the MFG Radio Network on Spotify, Apple Music, and on our websites, todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, defenseandmunitions.com, and evdesignandmanufacturing.com.